Good morning, good afternoon, good evening, everybody from around the world. Welcome to the next Sawtooth Software webinar. We're excited to be here today and have Chris Moore with us presenting SKU-Based Conjoint, a practitioner's guide. We'll introduce Chris here in a second, but we're excited to have him and see that many are joining. We'll just wait just a few more seconds here while people stream in, but excited to have everybody here today. Few details about the webinar. We don't use the chat feature in Zoom. There's a Q&A section at the bottom of your screen, and that's where you can ask questions. Feel free to type in questions during the presentation, and we will have time at the end for Q&A to go over all those questions. We get asked this a lot, but we always record our webinars and we send them out to everyone who has registered, and they're also available on our website after a few days. In this case, Chris is also willing to share his slides, so we'll be sharing both the recorded webinar and Chris's slides. I'm excited to let you know about some upcoming Sawtooth events. In January 22nd through 24th, we'll have an in-person workshop out in Orlando, sunny, warm Orlando, Florida, entitled Optimizing Features and Pricing Using Survey Research by our own president, Brian Orm. He's super knowledgeable on this subject and a great presenter. Highly recommend that you take a trip out to Orlando in January. And please put on your calendars that May 7th through 9th out in New Orleans, we will be having our Sawtooth Research Conference. It's an amazing event. We have a lot of great presentations planned and activities. You don't want to miss it, May 7th through 9th. And then this webinar series will continue, of course, into 2025. We have some amazing speakers lined up, and we'll be sending more information out about that. We try to do it about once a month, a webinar, and then you can also watch all of our past webinars on demand by going to sawtoothsoftware.com/webinars, or you can also see the URL there at the bottom of your screen for checking out our workshops and conferences as well. Just a little plug here for Sawtooth Software. If you haven't ever used us, we'd encourage you to check us out. We have a powerful survey platform. We do conjoint analysis and max diff really well, including all types of surveys. You can do all your surveys with us. We are easy to use and offer, we believe, the best support and the most friendly support in the whole entire industry. And you can try us out for free. If you go to discover.sawtoothsoftware.com, you can create an account and play around with it. But we'd love to get to know you. With that, let me introduce Chris Moore. Chris is actually just a really good friend of Sawtooth Software. He's been a friend of the company for as long as I can remember. Really nice guy. Get to know him. Chris is the head of data science transversal at Ipsos UK. Ipsos, if you don't know, has over 200 analysts, statisticians, and data scientists, engineers. Chris has over 25 years working in the marketing research industry, doing advanced analytics. He's a prominent figure in the global choice modeling community, and he's a regular presenter at our Sawtooth Software conferences and has also presented at New MR and Quirks. And by the way, Chris loves rugby, something that maybe he can talk to us a little bit about, but he was just telling me that he played, his kids play, he has season tickets. He loves the sport. So all those rugby enthusiasts, you have a friend in Chris Moore. Chris, how's it going?
Yeah, thank you, Justin. Yeah, thank you for inviting me. Really pleased to be presenting today.
We really appreciate it. All of our speakers put in a lot of time and effort, and we're just really grateful for you taking the time to share with us today. Go ahead and share your screen and turning the presentation over to you.
Great, thank you. Right, hopefully everyone can can see my screen. Yeah, thank you, Justin. Thank you, Sawtooth, for inviting me to speak. Really excited to be talking about this area. To give you a little bit of background as to how this paper came about, 4 or 5 months ago, my team were working on a really complex SKU-based conjoint. For those new to market research, new to consumer research, SKU stands for stock keeping unit. So they're just individual products that you might see in a supermarket shelf. And we had a really challenging client, and they really questioned all the work that we were doing. The client was really experienced in the area; they'd worked with previous suppliers, and they really challenged what we were doing, and basically told us, are you doing it right? Fortunately for me, I've been to a lot of Sawtooth software conferences. I think my first one was 2001, and pretty much been to all bar one or two. Since then, I've also been to a lot of Turbo conferences, which are additional events that Sawtooth put on. And across those conferences, I've managed to amass, quite an array of papers in this particular area from other authors. And, I was really able to use those papers, to convince the client that actually what we're doing is really seen as best practice in the area. So, I just really wanted to take time out to share some of those practices, so I've put together the best bits of the papers that I've got access to, and hope that hopefully it will help you, dealing with potentially challenging clients in the future. And you can just, talk about, what you're doing, and if you're not doing some of this stuff, then it might make you, at least think about, could you be doing, your work in a slightly different way. In terms of the flow of the talk, just a couple of slides on introduction. We're then going to look at the design aspect of things. So we're looking at what we call evoke sets. If you do these, what we call evoke sets, then there's potential bias that you might be introducing into your analysis. So I'm going to talk through a couple of papers that I've got access to about overcoming this self-selection bias. Of course, the modeling is, one of the most important elements, and price is, a very prominent attribute in this. So we're going to talk about, what is the best way to model price, because there's lots of different ways in which we can do that. Then going to look at the simulation side of things. So when you're presenting your simulation tools to the clients, some of these additional things that you can be thinking about in your simulation tools. Then going to end on a couple of papers that I've come across that, they introduce really easy concepts, and they really show how you can actually make a marked improvement in improving your share of preference estimates and get it much closer to market share. So we'll end on that note. One thing that I'm not covering, which is a huge area in itself, is volumetric conjoints. SKU-based conjoints are really synonymous with volumetric conjoint, because people are typically buying multiples of products. Like I say, it's a really big topic. Can't cover it in this webinar. Myself and Dean Tyndall from Sawtooth Software actually had a paper accepted for the Sawtooth conference in May, where we're actually doing an evaluation of volumetric methods. So hopefully maybe this time next year we'll be doing a webinar presenting those results. There's lots of papers out there. I've taken a lot of inspiration from papers from Tom Eagle, for example, who's come up with some very practitioner-friendly methodology. So if volumetric is something you really want to get into, then I'd recommend going into looking at those type of papers. Just by way of introduction, so why is pricing research important? And I think we all hopefully know the answer to that, because price ultimately influences consumer behavior, and it doesn't really take too much trawling on the internet to find some really interesting facts and figures when it comes to pricing. We can see that a lot of companies admit they've got room for improvement in their pricing strategies. So hopefully we can convince some of them to do some market research with us. Almost half of people are still really actively seeking out promotions and discounts, particularly, in the wake of the pandemic. More than 90% of people are likely to shop with brands that provide personalized offers. This talks a lot to menu-based conjoint. For those that are familiar with menu-based conjoint, it's the whole area of being able to build your own product or concept. So it's something to be thinking about. And there's still a real large number of people that are willing to pay premiums for different types of products, whether that's ethically sourced or sustainable products. When we think generally about conjoint, we think in our head, we've got an attribute grid, we have attributes down the side, levels across the top. And we, a lot of the time when we're doing conjoint, we're thinking about product optimization. So the attributes might be relating to different features of the product. When it comes to these consumer good markets, it's usually not the case because the product itself is fixed. We're not trying to add particular features to the product. So in terms of the design, it seems much more simplistic because typically we'll only have, maybe 2 or 3 primary attributes. The first is the product or the SKU. So the levels are just all the products that the client is wanting to test. We typically then have a price attribute. We don't normally have a single price attribute. We tend to have, a price attribute for each of the products that we're testing. And, in a lot of consumer good markets, promotions are a really big thing. So, a lot of the time we might be testing different promotions and different mechanics to see how that affects results. Now, in terms of new product development, in terms of how that works, like I say, rather than creating additional attributes and levels with, different types of packaging or different, sizes, typically any new product variants the client wants to test are typically additional products that you would add into that SKU-based conjoint, the SKU-based attribute, sorry. Again, if you think, of standard CBC, choice-based conjoints, it's normal to show, 3 to 5 product concepts. That doesn't really work, again, within consumer category because, typically we might be looking at 40 or 50 or even more SKUs. So we have to show more items on the screen. So it's very typical that we actually create these virtual shelves. You can see here, I haven't counted, but, there's probably around 25, 30 products on a screen. And we can do that because, again, we're just showing the product and a price and maybe, some form of promotion. But because we're doing this type of work, we need the thinking around it is a bit more complex, particularly around the design and estimation. And so that's what, for the rest of the talk, I'm going to be talking about some of these complexities and how we really overcome them. First area is what we call evoke sets, or some people like to call them relevant sets. We know that within this category, particularly in consumer categories, some product categories have literally hundreds of products. If you go to buy some cereal, there's lots of products. If you buy potato chips or crisps, as we say in the UK, again, there's an entire aisle worth of products. And while we can create those realistic shelves that we saw on the previous screen, there's a lot of information that respondents need to process. So, a common question we get asked is, what if we have too many products to show respondents? And that is where these evoke sets come through. As human beings, most of us, probably all of us, as consumers, we've already made trade-offs before we've even gone into the shop in terms of, which products we think are in our consideration set, or which ones we're likely to buy. So why don't we just simply customize the conjoint task to replicate that, and respondents will actually only see products that are really relevant to them and they're actually in their consideration set. It seems easy. So really be thinking about having evoke sets when you have lots of products, maybe to avoid a question coming up later in terms of how many products. One of our rules of thumb is if you've got more than 40 or so products in a conjoint, then we might start thinking about these evoke sets. But it might vary just depending on the category. And there's a reason we might want to do it is because we want to get more informative knowledge about the products that really matter. There's a lot of products which will have very low market share. So should we just concentrate on the high volume products to get really good information? And ultimately, we really want to reduce that cognitive burden. We don't want respondents to have to drop out because it's just too complex a task for them. Again, going back to that virtual shelf, just showing one task is hard enough, but then in the next task, it will be a different set of products. The products they like will be in a different position. So there's a lot of work that the respondent has to do to really give sensible answers. So how do we define these evoke sets? Well, there's no set way in which we do it, but the way in which we can go about doing it is we ask a number of questions before respondents go into the conjoint. If you think about the brand funnel, we've got our entire list of products that the client wants to evaluate. We might ask questions around brands respondents are aware of, which ones they would ultimately reject, which products they've purchased in the past. which ones they might consider purchasing in the future. And then depending on the category, there might be additional questions around pack size, format, required features, and so on. And I think I remember in a shampoo one we did earlier this year, there's shampoos for blonde haired people, there's shampoos for brunettes. So we asked a question about what their hair color was, so we could reject products which didn't suit their hair color. Now that might seem, well, why don't we do that on every conjoint? There are some disadvantages to doing that. We may be eliminating products ultimately that respondent might buy. We're just asking people for their considerations, but people are spontaneous. They walk down supermarket aisles. Something might appeal to them. There might be a really good discount. So there is that real possibility that we're going to miss out on share for some products. And also, without interventions that we'll be talking about, it will introduce some form of bias into both the design and the analysis. So we need to mitigate this through doing additional work. One of the common ways in which I've seen, in terms of solving the design bias, is that once you've asked these questions to reduce the full set of products into what we call the considered products, we simply just ask or add in some random products that has been rejected by the respondent in order to get a fuller relevant set. But actually what it does, it really helps with the bias. For example, if a respondent is super price conscious, they might have rejected all the premium products. So if they go through the conjoint, the software and the algorithms aren't really going to pick up that this person is very price conscious, because they're only looking at really low value products. So by adding in a couple of premium products, then we get a better understanding of whether this person is actually price conscious. There's also a couple of other benefits. For example, if we add in products, that means we get more exposure to some of the SKUs. A lot of conjoints we do, the client's insisting on including products that have got 1% market share. So if you've got a sample size of 1,000, you might only have 10 people that might realistically put it in their consideration set. So by adding in some additional random products, you're going to get some more evaluations of it, and to avoid you having to script in loads of dynamic conjoint designs, because each respondent's going to have a different number of products in their relevant set. By adding in some random products, you can reduce the number of designs that you have to build, because you can almost force it so that everyone must have, say, 20 products in their relevant set, for example. So if we summarize evoked sets, ultimately they're there to help us study many products. It helps customize the survey to what respondents are really thinking about in terms of purchase behavior, and hopefully that has the added effect of engaging respondents. We talked about adding non-selected products to the evoked set to help reduce so that bias. It doesn't take it completely away and may introduce other biases, but the consensus is that it generally helps rather than doesn't. But we do need to take into account that there are some biases with these evoked set designs, and we need to mitigate it when we come to the analysis. Which takes us nicely onto the next section around overcoming selection bias. As I said, when we are using these evoked designs, we actually need to address that certain items are not selected because they're actually inferior. The respondent actually rejected those products. Now, if we don't do anything, the absence of information when we're running analysis would suggest that the item was missing at random, which we know is not the case. So if we don't do something, then we're just going to simply be introducing bias by not penalizing these missing items. And we need to inform the model that they were missing because they were inferior, rather than just because they were missing at random. Now, across the papers I've seen being presented, there's two really main areas in which we can, or two approaches that we can do to help overcome some of this bias. The first is what we call adding a threshold parameter or a threshold concept. So we would add an additional parameter to our design matrix, and we'd add additional binary tasks to the main choice tasks. There'd be a binary task for each SKU in the design. And then if a SKU has been selected within the evoked set, they're coded as winning against this threshold concept that we've introduced. If a SKU is not in the relevant set, then they're coded as losing to this threshold. And then when we do the estimation in HB or other ways, and then we'd actually then discard this threshold parameter afterwards. But by doing that, we're helping inform the upper model that some of these products, are definitely inferior to others. Second methodology is actually we just pretend that all products were shown within the choice task, but they were just simply never chosen. So across all the choice tasks, these products aren't going to be chosen, so it will naturally lower the utility scores of those missing items. And because it's repeatedly not being chosen, then we can make the assumption that these products are actually inferior. So that's another way in which we can get around it. This is where I want to talk about one of the studies that I've seen and I refer to quite a lot. It's from Kenneth Fairchild, who used to be at Sawtooth Software in 2016, and he did a lot of simulation work looking at different ways in which you can try and mitigate the bias. So he took a real study and he created a baseline cell. So we had 100 products and he had true utilities for those and introduced some Gumbel error. And what you could do is use this baseline as a benchmark to compare the other cells against. He created a naive approach. So we just draw the top 30 items for each respondent, but didn't do any of those corrective procedures. So no threshold, no including all the concepts. So this is what we call the naive approach. So what would happen if you did nothing. Cells 3 and 4 are then the threshold approach and the approach where you include all the products. In these examples, he set, with it, the mid price for the products. So in the augmented tasks with the binary tasks, you had the SKU, and then you just set it to the mid price. And for the cell 4, for the products that weren't in the relevant set, again, he set the price of those products to be the mid price. Cells 5 and 6, these were replicates of the previous two, but rather than using the mid price, he used a random price point. And then in the final one, he took the threshold approach where we added in these additional binary tasks and simply just replicated those binary tasks 3 times to try and essentially give those binary tasks more weight when it came into the modeling stage. So across those 7 cells, Kenneth did a lot of work. So he knew the true utilities. He had, I think, 6 holdouts in his analysis. So he evaluated the shares of preference on those holdouts and took the log of those shares of preference and then looked at the correlation of the true shares of preference against the results from each of these cells. So the higher the number, the better in this case. We're looking at correlations. We'll ignore the logic for now because most of us do hierarchical Bayes. We can see cell 1's the baseline and has an almost perfect correlation. The winners in this case were cells 3 and 4, which was the threshold approach and including all the tasks, but using the mid price. And you can see for cell 2 that actually had the lowest correlation, and that was the one that didn't address any selection bias. He then looked at what we call mean absolute errors. So he fitted a linear model between the truth and the results from these cells, and then just simply computed the mean residuals between all the points. So in this case, the lower the number, the better, because if it was 0, you'd have a perfect relationship. Again, the baseline cell is doing extraordinarily well. And in this case, cells 3, 4, and 5 did a really good job. And again, were much better than cell 2, which was the cell which had no selection bias. In the same year, there was also another paper from Kinnett and Teen from Ipsos. They actually use different terminology, so just be careful when reviewing any papers because people do use different terminology. So what these authors used, what they called augmented. Kenneth in his one called the threshold approach. So in the brackets, you can see the terminology that was in the previous paper. But ultimately, they came pretty much to the same conclusion that the threshold approach works much better than any naive approach or any other approach. Models 3 and 5 differed in terms of how they were estimated. So the model 3 was using CBC-HB. Model 5 was using an R package, which I've just put there. I've not used it myself. They concluded that, that both models worked really well. The R approach they found that had a bit of better internal validity. Model 3 using the Sawtooth CBCHB ran a little bit faster in their estimation. They also looked at some work, I talked about including a threshold parameter. They looked at, what would happen if they didn't include the threshold parameter and just used the non-option as a proxy, but they found that you do need to have that threshold parameter. So don't just use the non-option as a proxy. You do need to include this extra parameter to help inform the model. Summarizing that section, so hopefully you saw, particularly from Fairchild's paper, that there is bias from self-selection. You do end up with slightly worse models if you do nothing, and generally found that any method that is used to try and address that self-selection certainly helps more than it hurts. And both authors came to the conclusion that the threshold method seemed to be slightly more robust than when you just include all the items, but there really isn't too much in it. So I think it's just whichever one is easier for you to apply. But I think the ultimate taking out of this is you must try and do something rather than just leave the model to try and work out whether these missing items are missing at random or missing to their inferior. We talked about the design stage. Now we're going to talk about the modeling and particularly the modeling of the price function. We know there's lots of ways in which we can estimate price utilities, but the main holy grail is which one is actually best. A couple of my ex-colleagues from GfK, so Dmitry Lekovsky, James Pitcher, and Kirillov, about 3 years ago, they conducted a really good study looking at multiple countries across multiple categories to really identify whether there was an optimal way to model price. And this is what so the next few slides, we're going to talk about their paper. They took studies with around 15 products or 15 SKUs. They had different price points for each of the SKUs. A lot of the best practice in this area is that typically one of these price points would be your current price, and then each subsequent price above or below would be a certain percentage increase or decrease. So in this case, I think price 3 might be the current prices, and then price point 4 is 5% higher. Price point 5 is 10% higher. Again, it's common convention to then round the numbers to a psychological point. So products in this category always end in a 9, then just round it up or down to the nearest 9. Now, when it comes to different options, there's lots of ways in which we can actually model price. There's, we can model price as a linear term. We can model it as a log linear term or a part worth term. We can also model it as a single price attribute, like we might do in standard conjoints, or we might have, lots of alternative specific attributes. So, a price parameter for each product. And so this is what the authors set out doing. So they tested 6 different price mechanics. You've got the products and the prices on the left. So in the first test, they just created a single price attribute with just one term. So it was a linear attribute. They again just created in the second one just a single price attribute, but had part worth terms. So we had 5 levels. There were 5 prices. In the third area, they looked at doing alternative specific pricing. So a separate price attribute for each product, but using a linear term. In the fourth one, then they looked at alternative specific pricing, but then using the part worth term. So again, you can see here that we've gone from option 1, which is just modeling a single parameter, to option 4, where we're actually now going to be modeling 90 parameters. So it could potentially have a lot of burden on the modeling side of things. They also looked at 2 additional approaches, which we call like price tiering. In the first methodology, they looked at just 3 tiers, essentially low value products, mid value products, and high value products. And then they looked at a more customized tiering. So what they actually looked at was they looked at count data. You can see a number of products here have got very low market share, so it might not be appropriate to create price parameters for those products because you're going to have very sparse data in your raw data. So they've collapsed a lot of products into smaller tiers. So in this case, they've got 8 tiers, but no one tier has just got a product with a very low market share. Now, the good news is that in their holdouts, they tested that there's actually very little difference in shares of preference, regardless of which methodology they used. Of course, you can see a couple of differences. Brands 9 and 5 and 6. Really, there wasn't more than 1 or 2 percentage points different, and probably very little difference in terms of ranking. Where they did see big differences, though, was in the price elasticities. So on the graph on the left, these are the two models where they just created a single price attribute, so the linear term and the part worths. You can see, a lot of similarity between the two, maybe only, a couple of differences between brands 10 and 11 and maybe 5 and 6. They then overlaid the price elasticity for the alternative specific methodologies. You can see now, particularly for brands 10 to 14, there's got some real extremes in terms of the elasticities. A couple of brands have now essentially got 0 price elasticity. A couple of ones have got, their price elasticity is more than doubled. So there's certainly some issues there when you've got the product level alternative specific designs. Perhaps getting a little bit busy now, but then we overlaid the final two models with the price tiering. You can see that for those brands 10 to 14, it was much more in line with the one attribute elasticity, so we don't get those extremes. There are some differences between brands 5 and 6, but they mentioned that those brands have their own price attributes, and that's why they believed it increased the elasticity for those two products. So in terms of the recommendations from the authors for this paper, they said that when the sample is not large, estimating a single price attribute is not so bad. It's fast, it's fairly stable, and can have high predictive accuracy. If you are going to go the alternative specific design route, to maybe think of linear coding, that's probably just because of the number of parameters that needed to be estimated. But they also suggested that creating these price attributes by tiers is a really good alternative. It helps with the stability and keeps the accuracy really high. And for us at Ipsos, we tend to favor this one, but it's because we've typically got more than 40 or 50 SKUs. So to have a price attribute per product is just not really realistic. So that's the area that we tend to favor. And in order to question is really, how do you calculate these tiers? So again, these authors talked about count analysis. So brands with really low penetration shouldn't be used on their own. So they needed to be collapsed. There was another paper from Belyakov in 2015 who also suggested running aggregate logit models with 15 linear prices, and then maybe collapsing into tiers the products that actually have pretty similar price coefficients. There was also another paper which was at the Sawtooth Software Conference this year in San Antonio from author called Minocha. She also talked about count data, but talked about sometimes it can be really noisy, particularly when you have low involvement products with small market share. So to overcome this, she talked about a methodology that she did to try and create these price tiers. So the flow was you've got your raw choice data. She ran an aggregate logit model, but she included full interaction terms, not just main effect terms, but full interactions. So for each product and each price for each product, we can get a utility. She then exponentiated those utilities. So now we've got for each product, if there's 5 price points, we've got 5 exponentiated utilities. She then transformed that data at a product level to sum to 100%. Then she took that data and put it into a standard cluster model to then use the cluster analysis to then group the products together into the different tiers. Some of the conclusions she talked about, like the previous author, that at the design stage you should really have a price attribute per product in terms of when you're creating the design. So each product has its own price range. But she concluded, that price tiers work really well. They work better than alternative specific ones if you've got lower sample sizes, and they still capture, important nonlinear points compared to just full interaction models. If you go in that route. Probably the one thing that I should say is that both these papers looked at projects with only like 15 SKUs in them. My colleague Angela Budia is actually going to be doing some work over the next few months, and we'll be presenting at the Turbo conference, which will be happening in conjunction with the Sawtooth software conference. I think it happens the day before. So she's going to be doing some work where we're looking at pricing when we have many more SKUs, just to see if the tiering is still better than the individual alternative specific approaches. Bit of a tangent here, but along the same lines. I want to talk just one slide about line pricing. It's probably something that's not used very much at all. And to be honest, we don't use it very much either. In a lot of these categories, you have a product, say Coca-Cola, they've got lots of different variants. Now, the chances are that ultimately the client is going to either increase all their product variants or decrease all of their product variants. Probably unlikely that they're going to increase some, decrease others. So if it is the case that the client is going to only increase all the products together or decrease all the products together, then you might want to consider what we call line pricing. It's an approach where it can't be done directly within Sawtooth software. You'd need to export the design and make some manual manipulations afterwards. But if your client is only going to line price, then create designs where within a choice task, all the products for that client all go up by the same percentage amount or go down by the same percentage amount. And if your client is unsure, then maybe create designs that contain a mix of these line pricing choice tasks and the random pricing choice tasks that would normally come out of your design. So just something to think about. Maybe it's a question to ask the client when you get commissioned with a project. If we looked at the design, we looked at some of the estimations. Now we'll go on to the simulations. Again, a lot of people, when they're buying, are typically buying similar products. They're not going to buy products that are completely different from one another. And if we don't account that, there are lots of similar products, it can be problematic. If your client has got 15 product variants that they want to include into their product line, if you start simulating these 15 additional products, then all of a sudden you're going to see that the share for the master brand is going to keep going up and up and up and up. And you might then conclude, yes, sure, add all 15 variants, you're going to increase your market share. And that's not really the reality. And also, if we test lots of SKUs, we're going to create problems with sourcing. So, if you introduce a new product variant, where's it going to get its share from? And if we're testing lots of SKUs, particularly lots of similar SKUs, then you're going to have some problems with where that share is actually coming from. Understand that there's probably a lot of people on this call that are very familiar with conjoint and very familiar with an issue, a famous issue within conjoint terms called the independence from irrelevant alternatives. But hopefully there's some people that are new to conjoint or less aware of this issue. So I just wanted to make you aware so we can talk about these nested simulations and how they can help. If we have a simulation here, so we've got 3 products all around mode of transport. We've done our analysis, our hierarchical beige. We've got our utilities. So we have a utility for the car of 6, a utility for the train 4.5, and a utility for the red bus of 5. If we plug that into a standard logit model, so if we want to calculate the probability of a car, we would take the exponential of the utility for that car, which is 6, and then divide it by the sum of the exponentials of the utilities for all the products in the simulation. And if we do that, we get a probability for the car of 0.63 or 63%. We can then do that for the other products in the simulation, and so we're going to get some preference shares, and then we can talk to the client. These would be your preference shares. But your client asks, well, what about if our competitors launch a blue bus? What's going to happen? So you want to then simulate, which is essentially a near identical product. Instead of being red, it's blue and slightly different shape in this case from the picture. But through your simulation work, the utility of this blue bus is also 5. Now, common sense would suggest that when we go to our look at our original simulation, the blue bus is only going to take share from the red bus. There's no reason why it should take share from the car, unless someone particularly likes the color blue in this case, and it shouldn't take from the train. So really that 23% should be split between the red bus and the blue bus, so they both get nearly 12% share each. However, that's not the case. If we look at aggregate logic models, what would happen is that the shares for the blue bus would actually take share from all the other products. And what you'll end up seeing is that actually the probability of the red bus and the blue bus combined would be significantly higher than 38%. You can see that the car is the biggest loser here. It's actually losing 12 percentage points, and the train is also losing. And that's because with logic models, the change in share is based on this, what we call proportional substitution. So one way that we can get around it, we'll talk in a couple of slides time about actually doing it within the estimation. So you can do what we call nested load estimation. But if you're just looking at the simulation, we can try and overcome some of this IIA by creating what we call nests. This is a very simple example. So we just have two nests, one for public transport and one for car. And in the first step, what we do is identify the maximum utility within a nest. So for public transport, that would be 5. For the car, it would be 6. We then just plug that into the standard logic model. So we have a probability for the public transport nest of 27%, and then for the car of 73%. Then as an additional step, within any nest that has multiple products, we use that nest probability as a weight to then calculate the probabilities of products within that nest. So in this case, the red bus would get 17% and the train would get 10%. I don't have a slide on it, but if we take this one step further, if we added the blue bus, so we put the blue bus within the public transport nest. If we look at step 1, nothing's changed because the maximum utility for the public transport nest hasn't changed. Nothing's changed from step 2 because we're just doing the numbers of the utilities haven't changed. But in step 3, rather than 27% being split across 2 products, it's now being split across 3 products. Now you're still going to get some of this IIA within that nest, but what you're doing is you're preserving the share of the car, because we know that the car has, there should be no reason why adding in an identical product in the public transport nest should have an effect on the car. The common question then is, well, how do I calculate these nests? There's common sense is certainly one way. When I have done it in the past, we've talked to the client and the research teams, and we might simply just create the nest based on brands. We know a particular brand has got lots of product variants that they want to include, so we might just create the nest at a brand level. If you want to get a little bit more sophisticated, Kevin Lattery, who's now at Skim, did a paper, I think it was at a Turbo conference, showing how you can maybe look at creating these nests. So you might have a number of respondents that we've got on the left-hand side. This would be an easy example. So there's only 7 products, A to G. Brian, in his choice task, only ever chose products A, B, and C. Keith only ever chose products B and D, Dean A, B, and E, and so on. Then we can just create a calculation based for every pair of products of whether each respondent chose A or B, or A and B. So we can see that Brian chose both A or B and A and B, but Keith chose B but didn't choose A and B. So if we can create a score here for the overlap of A and B, which is in this case 3/4 and 3/4, so 3/4. And then we can just replicate that for every combination of products. And so we can get an Excel table like the below. And then you can just use simple techniques like hierarchical clustering. So an example of some R code that Kevin used. You can use SPSS for creating hierarchical clusters. And using this data as a distance matrix, you can create what we call dendrograms, which a bottom-up approach. So it looks at products which are very similar, and then just keeps grouping products that are fairly similar. And what you can do here is you can create cut lines across these lines to start identifying different nests. So you might, depending on how many nests you want, you might think that, okay, well, this is one big nest. You might think, well, actually, this nest is very different to this nest. So you've got a couple of nests here. You have a nest here of 4 products, and so on. And so you can look at these cut points. You can review the SKUs within those nests to see if it makes sense and how granular you want to get to. So that's just looking at it when we're doing the simulation. So we've done the estimation as we normally would, but there are other approaches that we can do directly within the estimation. Now we know that hierarchical based through Sawtooth, the IIA is still present at a respondent level, but overall the effect is reduced. Now Kevin's done a lot of work looking at individual nested logit models as well. He's got papers 2016, also 2023. I'm sure he's got others as well. It is a complex estimation procedure, so it's not for the light-hearted, and probably needs a lot of programming skills. There's also multinomial probit models. So these explicitly consider some correlation between the different products within the covariance matrix. Same challenges here. It's not implemented in common software, so you do need to have a real good theoretical understanding of these models. At the time, there's no closed form expression. It's very difficult to implement within Excel simulators as a result of that. So again, probably stuff people aren't using because it is really hard to do, but there are approaches out there if you want to try and capture this IIA within the estimation procedure. Final couple of slides. I think we're coming up to the end of the hour. Over the last 2 or 3 years, again, like some ex-colleagues, Alex Kirilov and James Pitcher, have showed that, well, firstly, they were looking at, how well does conjoint data relate to real market share data. Within their company, they actually have access to real world data, and they've shown that actually conjoint data is better than actually stated preference data. So rather than just asking people what product they would buy, going through a conjoint actually gets you much closer to market share data. And they started looking at, what if we adjust this for distribution, or what if we adjust the models for awareness? And what they found is that adjusting for distribution single-handedly, gets you really close to actual market share data. And actually adjusting for awareness is actually a really bad idea. So again, if you're within your simulation tools, if you're not doing already, you might want to consider, weighting your shares of preference for each of the products, by the distribution effects. And final slide from me, has been a really big area over the last 2 or 3 years. There's a fantastic paper from Peter Kurtz and Stefan Binner in 2021. It's a very simple approach. All they were doing, they identified 9 questions, which split across 3 areas of price, brand, and innovation, and simply just asking respondents to answer these questions, got respondents to think more about their choices that they make, and what they showed is that when they looked at what we call mean absolute errors, there was an improvement of about 10% in terms of what was simulated versus what these holdout tasks. So it showed just by answering these questions, you'll get much closer. You can also include these questions as covariates in your estimation to again think about getting more accurate data. Because it was such a really big thing, it won Best Paper in 2021. Brian Orme, who's on the webinar today, and John Godin and Trevor Olson from Humarius also did some work to validate it, because it was such an unbelievable result. They did validate it, but also suggested improvements via a max diff exercise. So it might be a little bit longer, but they also showed that doing it via a max diff exercise even improved results further. And there was another paper again from Skim last year. There's suggestions that 9 questions is quite a lot of real estate. So then what they showed, they ran some factor analysis and showed that actually you can get away with 3 or 4 statements with only a minimal reduction in accuracy. So again, be thinking about maybe adding these types of questions within your surveys, because you do tend to get more accurate results. Acknowledgements, so like I say, I was just presenting an ensemble of papers. These are all the papers that I referenced in this talk. A lot of them are available on the Sawtooth Software website through the proceedings. I'm sure if you contact me via LinkedIn, if you want access to particular papers, I'm sure I can find. I've got access to them, so I can send them through to you. So on that note, I'm going to hand back to you, Justin.
Thank you, Chris. Really appreciate it. We'll be having some Q&A next. And Brian Orm has been answering a lot of the questions behind the scenes. But Chris, I think we're going to want some of your comments on those questions as well. Before we get to those, again, thank you so much, Chris, for that amazing presentation and all the references and all the hard work that went into that. We look forward to listening to you in the May conference coming up. As you can see on the slide, May 7th through 9th in New Orleans. And Chris, there'll be that turbo session the day before, right?
Yes, that's right.
And you'll be presenting?
Yes, I will be. Yep.
Cool. Yeah, then just a reminder, January, the in-person workshop in Orlando by Brian Orm. You should go out to that one. And then more webinars coming next year. If you don't know much about us, if you've never used Sawtooth before, we encourage you to check us out. We do all kinds of great stuff, especially good at conjoint and max diff. And a lot of people don't know that you can do all your surveys with us. We have randomized blocks and all kinds of stuff that you can do just with your regular surveys. And with that, we'll get into the Q&A. Chris, can you see the Q&A section here?
I can see two open questions from Pavel and Aprami.
Yeah, would you mind reading and answering those, and then we may go into the open section.
Sure. So there's a question: why nested simulation and not first choice or randomized first choice? First choice will allow us to track share redistribution. So price of ketchup has gone up by 10%, and respondent B now gives the highest utility to the competitor ketchup. So randomized first choice is certainly a valid methodology. It's one of the ways in which the community and Sawtooth have looked at trying to overcome this independence from irrelevant alternatives. If you're simulating, a lot of companies have their own Excel-based simulation tools. If you're doing randomized first choice, Sawtooth have a randomized first choice simulator, so it's something that can be done. But the way randomized first choice works for those that are not familiar with it is that it will actually run like 50,000 iterations and putting what we call gumball error into the utility, so you get a little bit of variation. That is certainly an alternative to nested simulations. First choice within consumer category markets, from my experience, doesn't work too well. As you've mentioned, if you've got two products, one's got a utility of 4, one's got a utility of 3.9. If you have a first choice and you're giving 100% share to the one with the utility of 4, but the reality is, the shares are almost 50-50. So I think, I'd maybe caution against first choice because of that, because people aren't as black and white as that. First choice for me is normally more around when you have really low involvement categories, like you're buying a boiler, for example. You're not going to be so you're buying it once every 10 years. You're really only going to buy the product with the highest utility. Second question: behavioral priming questions. Are they used for segmenting respondents and use it for some sort of calibration? What the authors showed is that they're not actually using it for segmenting respondents. That is something you certainly can do. I think they, from memory in their paper, they created quadrants, and you certainly could assign people to quadrants and use those as covariates within the estimation. But actually, what they showed is that you literally just need to show the questions. You might want to do supplementary analysis, and include, create segments and add them into your conjoint tool, so you can see, well, these are people who are price sensitive and what they do and so on. So yeah, you can use it for segmenting, but you don't need to. You just need to actually ask the questions. Yeah, so thank you. Note just to say, yeah, thanks for the refresher. Another question around for individual thresholds, you're adding additional binary tasks. Can you say more about on the design? What does the binary task look like? Sure. So you've got your standard choice tasks. So within the software, you can export the design. So you have you'd have a row for each product in the choice task. So you have those, and then additionally, you'll just add in tasks which just have two rows. So you've got one row relating to the SKU. So you have, you've got your attributes as columns. So you have, for attribute one, which is your product attribute. So for SKU, you'd have a one because it's SKU one. Everything else would be zero, unless what Kenneth showed is that you might then want to set the price as price point 3, but everything else would be 0. Well, not necessarily price point 3, whatever the mid price is. The second concept would have zeros for all the parameters except for this threshold parameter. So in the first concept with the SKU, the threshold parameter has a value of 0. For the second concept, it has the threshold parameter is given a 1. So there's very little information there, but you're basically comparing each SKU against a threshold concept, and then you've got a column with your answer. So if the SKU was in the respondent's choice set, that row 1. If it wasn't in the respondent choice set, then that threshold concept 1. So for the follow-up to that, do you mean the conjoint data with the binary task data once you've collected the data? Yeah, so you do all that data in the modeling stage after you've collected the data. Like I say, you can't do it directly within. If you're using Sawtooth software, you can't use it. You can't model it directly within there. You'd have to export the design. You would then create these additional binary tasks, and then you put that data then into the standalone version of CBCHB if you're using Sawtooth software.
Hey, Chris, there's one more, if you wouldn't mind. Okay. If you click on the Answered tab, you'll see there's one from Jacqueline, more towards the bottom.
Okay.
It says for evoked sets.
So the question is, for evoked sets, is there an issue to show respondents a different number of SKUs on each screen, hiding alternatives that they said they'd never buy, rather than randomly pulling in rejected SKUs so that each screen has the same number of items? I think at the back end, it worked to assume that respondents saw all SKUs in their design. So I think from the work that Kenneth showed is they are the two options. So you either create an evoked set and show respondents a fixed set of products. Does it? Yeah, I guess. So in terms of how you think about doing the analysis, creating the design, so the way that we would probably work is that we'd actually create a task with, when we submit our task to the scripting team, we would have the task with all the items on there. And essentially all our scripting team is doing is suppressing the products that aren't within that respondent's relevant set. So I think there really is issues. There's not really an issue with different numbers of SKUs on each screen. Obviously, you want to make sure that there's enough products on a screen. You just need to make sure that you don't want to be setting up designs where there's only 1 or 2 SKUs left because all the other SKUs have been removed through the relevant set.
Chris, do you have a little more time? We have 2 more questions that came in. Are you okay to go?
Yeah, sure. Are they in the open questions?
Yeah.
Okay. Is it not the case that IIA is only a feature of aggregate logit and not mixed logit HB? So IIA is a feature of individual level data. It's obviously worse aggregate level data. I think I got into the conjoint in the late 90s, and what we know as choice-based conjoint really wasn't very popular because you could only create aggregate level Utilities. I can't remember what it was called. I think it was called like ICE, but you could create like segment level utilities. And it was only when HB came around that that people started using CBC as opposed to some of the more traditional conjoints. But if you think about a respondent level, you still have IIA in the analysis in the respondent level data, but it's just much mitigated. Trying to think about if you've got two respondents and if you've got two products, two respondents. Respondent A really loves product A. Respondent B really loves product B. So at an aggregate level, it's 50-50. If you then introduced a product a very similar product to say product A, you're going to get a lot of IIA for one respondent, but you're going to get none for the other. So it sort of it mitigates it quite a lot. I say it doesn't eradicate IIA. To the previous question, randomized first choice is another way of trying to get over this IIA because you're not just looking at one simulation; you're looking at 50,000 simulations with slight random data, randomized data within there. So I think, it's HB doesn't solve it perfectly. I've never used mixed logit models. I don't know if they are better than HB models. So I might leave that to one of the academics. Final question. So someone is pursuing a PhD. They'd like to inquire about the applicability of conjoint analysis in assessing the preference of both patient and healthcare professionals regarding service modalities that present two distinct options. Unfortunately, I don't work in the healthcare area. If you contact me separately, either on LinkedIn or email, my name is just first dot last name at ipsos.com. I can forward that to our. We have a specific healthcare team, but they do a lot of work based on both on patients and healthcare professionals. But I think it probably requires a wider discussion on that. But I'm really glad that you're actually pursuing a PhD in this area. The more people we have, looking at ways in which we can model this data, then the better.
Yeah, and Emmanuel, you can email me, justin@sawtoothsoftware.com, and we'll get back to you as well on our answer on that. Thank you, Chris. Really appreciate your time today. We look forward to seeing more of you at our conference next year. And to everyone for coming today, thank you for showing up and have a great day. Until next time, see you guys later.